Hello everyone, welcome back to our lesson video 8 of programming with C++. By the end of this video, we are going to understand what namespaces are and how to use them effectively, and how to work with different types of namespace, including built-in, inline, and anonymous namespaces. Understand compilation of program structures in C++, and create and use header files to organize your code. Handle exceptions properly using try-catch blocks, and write robust program that can handle errors gracefully. So without wasting much time, let's dive into it. So namespace. What are namespace? Let's take it as this way. Namespace is like organizing files in different folders on your computer. Just like you might have a photos folder and a document folder to keep things organized. Namespace help us organize our code by grouping related items together. A namespace is a feature that provides a way of grouping related identifiers such as variables, functions, and classes under a single name. It provides a space where you can define or declare identifiers. Is in essence, a namespace defines a scope. Why do we need this? Imagine you are working on a large project, right, with multiple programmers. Two programmers might create function with the same name, like print. Without namespace, the compiler would get confused. Then confused. Namespaces solve this problem by creating separate containers for these functions. So creating a namespace is straightforward. It begins with the keyword. Begins the keyword namespace followed by the namespace name. Like this, namespace and the name. The example namespace programming. So this is the name of the namespace programming. So let's take it like creating a labeled box called programming and putting your function inside it. So this is the name of the namespace programming. That's how it works. So accessing the members. Once you created a namespace, how do you use what is inside? You need to tell the compiler exactly which box you are looking in. We access namespace. You access members of a namespace using the scope resolution operator, which is the two columns. And this is the example. So the namespace name, two columns, and the member name. And the member name. So this is an example of the namespace. So namespace name, which is the programming, and the member is inside programming namespace. So it's like saying, go to programming box and get me the function, the function fu and this function. So namespace with using directive. Sometimes typing namespace name with two columns every time can be tedious. So using directive it's like saying I'm going to be using items from my specific box a lot. So just assume I mean this box unless I say otherwise. The using directive The using directive tells the compiler that the subsequent code is making use of names in a specific namespace. So for the namespace using directive, you have your namespace name, and your member is a fun, fun, fun. So this is exactly what we do when we write namespace using namespace std then intermediate. At the top of your program, you are telling the compiler to look in the std namespace for things like cout and cin. You have namespace types of namespace. These are all examples of the namespace using directives. You have types of namespace. You have the built-in namespace, the inline namespace, the anonymous namespace, and global namespace. So the built-in namespace are like pre-installed apps on your phone. They come with the C++ and contain useful functions and objects that you can use right away. These namespaces are part of the C++ library and contain most of the built-in functions, objects, and classes. They also help avoid conflict between users-defined and library-defined functions or variables. The most common built-in namespace is the std, which is the standard. The std namespace contains most of the standard functions, objects, and classes like the cin, the cout, the vector, string, and many others. So this example of the built-in namespace. Using namespace std. Without the using namespace std directive, you need to explicitly specify std before standard library functions. So before we write every line, we write std two columns before this line, std two columns before this line. By using namespace std here, we don't need to bring the std with two columns over here. So let's go into inline space namespace. An inline namespace is like having a box within a box, like a folder within a folder. But the inner box is so convenient that you can access its contents directly without opening its first box. In an inline namespace, its members are accessible directly without using the namespace name. It's like declared using the inline keyword. So this namespace, you can declare it straight using your inline namespace. This is particularly useful for versioning libraries while maintaining backward compatibility. Example, and we have the anonymous namespace. Anonymous namespace is like having a private room in your house. Only people in that specific house can access what's inside. An anonymous namespace doesn't have a name. It ensures that the entities in the unnamed namespace are limited to that specific file. This is useful for creating file local variables and functions. And this is the example of the anonymous namespace. So anonymous namespace, you just namespace and nothing else. Int value. So this will be the outside your main code, which is the global scope. Outside the main code, then you come back here and access it inside the main code to see out value. it's going to print the value 10 for you. So variables and functions in anonymous namespace are only accessible within the same file. How the exception handling. One important thing is the exception handling. Imagine you are cooking and something goes wrong. Maybe the stove stopped working or you run out of ingredients. Instead of you just stopping and leaving everything in a mess, you have a backup plan. Exception handling in programming works similarly. So exception handling is based on keeping the normal functionality of the program separate from error handling. The basic idea is that errors occurring in one particular part of the program are reported to another part of the program, known as the calling environment, which performs central error handling. That's the exception handling. And these are some components of exception handling. There are two main types of the parts of the implemented exception handling. The first one is the part of the program that can throw exceptions. This is where problems might occur. And the exception handlers that will process the various exception types. This is your backup plan. It's like having a fire alarm system. The smoke detector, which is the part one, detects the problem and alerts the fire department, which is the part two, who knows how to handle the situation. So try and catch block. C++ provide inbuilt features for handling an exception using try and catch blocks. The try block contains code that might cause an exception. It's like saying, try to do this, but prepare for problems. And a catch block contains code that handles exception. It's your backup plan when things go wrong. And this is the example for the try and catch block syntax. This is the syntax. Try, the code that might throw an exception goes here, and a catch exception type E also goes here. Throwing exceptions. So throwing an exception means returning some kind of value that represents the exception from try block. It's like raising your hand to say, stop, there is a problem here. The matching catch block is found using the type of the thrown value. So the throw keyword is used to throw exceptions. And this is the syntax. The syntax for throw. The throw exception value for your throwing exceptions. So there are three types of values that can be thrown as an exception. You have the built-in types like ints, character, extension, etc. And you have the standard exceptions, which are the predefined exception classes. You have the custom exceptions, your own exceptions classes. So this is throwing built-in types of code. Int x equal to 7. Try if x modulo 2 is not equal to 0. Throw int. Throw -1. That's the example code for the throwing built-in types. Int x equal to 7. Try if x modulo 2 is not equal to 0. Throw -1. More examples. So we have throwing standard exceptions. Standard exceptions are like having a professional emergency response team. They are predefined classes that represent different types of common exceptions. All these classes are defined inside the STD except header file and are mainly derived from the STD double colons exception class. There is the C++ exception hierarchy, the logic error, invalid argument, domain error, length error out of range, the bad cast, bad function for runtime error, which is the range error, overflow error, and underflow all goes into the exceptions. So benefits of handling exception. Exception handling provides several important benefits. First, separation of errors handling code from normal code. Your main logic stays clean and readable, while error handling is organized separately. And two, functions can handle only the exceptions chosen. You can only choose your exceptions to handle and which to let propagate up to calling functions. And three, grouping of error types. You can handle similar types of errors together, making your code more organized. So exception handling makes your program more robust and professional. I have a separate compilation. Now let's talk about how C++ programs are structured and compiled. So think of building a house. Instead of building everything at once, you might build the foundation first, then the walls, then the roof. Each part can be built separately and then combined. This is similar to how C++ handles separate compilation. In C++, you can write different parts of your program in separate files and compile them individually. Later, these compiled pieces are linked together to create the final executable program. This approach has several advantages. One, for faster compilation, only change files needs to be recompiled, better code organization, easier teamwork. Different programmers can work on different files, and code reusability. So with this where you write to code the editor, then you process the code, compile it, and link the code, and later load to your memory for execution. This is the steps the program goes through. So let's go into header files. Header files are like instructions, manual, or blueprints. They contain declarations that tell the compiler what functions, classes, and variables are available, but not how they are implemented. In C++, header files may or may not end with the H extensions. Header files are basically used to declare the interface of a module or any library. Header files are like a restaurant memory. It tells you what dishes are available in and their names, but it doesn't tell you the recipe for making them. These are some components for header files. We have the function declarations. These are what functions are available in the header files, and data type definition, custom data types you've created, and macros, preprocessor definitions. header file. This is the syntax for header. So hash include, then your file name here. So hash include iostream, which is the header file for input output stream. Now header files importing. So importing header files, we import header files into our program using the preprocessor directive hash include. These preprocessor directive are instructions to the compiler that these files need to be processed before compilation. It's like telling your compiler before you start compiling my program, right? Please read this instruction manual first, right? So the preprocessor literally copies the contents of the header file into your source file at the point where the hash include directive appears. Types of header files. Now the standard header files with the pre-existing header files, and we have the user-defined header files. So let me explain each header files. For the standard header files are like tools that comes with your C++ compiler. They are already there and ready to use. You just need to include them in your program. These files are part of the C++ standard library and provide commonly used functionalities. They contain declarations for standard functions, constants, and classes. So common examples of the standard header files are the iostream, the CMAT for math calculation, this for the input output stream, the string, the seno, and the vector. And you have the user-defined functions. The user-defined header files are like creating your own toolbox. These files are defined by you and you can import using hash include and the file name. There are many used to encapsulate your own functions, classes, or declaration, and organize your code better. To reuse code by separating it into different files and make your main program cleaner and more readable. So write user-defined header files. To create a user-defined header files, write your C++ declaration and save it with the H extension, with this extension. Then the second one is include your main program using hash include and your file name .h. So in sum of two numbers, int A, int B, A plus B. Example of writing header files. Another example is hash include, because you are going to perform calculations. So the header file is going to be hash include. Instead of iostream, you can write this hash.h as your header file. This is when you are creating your own header file.